The mole. The mole is a unit that contains the same number of particles as an atom of 12 grams carbon contains. The mole uses the unit that is called the Avogadro's number, and it means that 1 mole is equal to 6.02 times 10 to the 23rd atoms. 1 mole of carbon, 1 mole of sodium, 1 mole of gold, they are all equal to 6.02 times 10 to the 23rd atoms. In a covalent compound, Avogadro's number has equal to the same mole of molecules. So for example, 1 mole of CO2 is equal to these many molecules of CO2. When we have an ionic compound, depending on the number of atoms, for example, if I have 1 mole of sodium chloride, I have 1 mole of sodium, 1 mole of chlorine. So I will have 6.02 times 10 to the 23rd atoms of sodium and 6.02 times 10 to the 23rd atoms of chlorine. Avogadro's number can be written as a conversion factor. We say 1 mole equals to these many particles. And then we could write conversion factors. These many particles over 1 mole or 1 mole over these many particles. And why do we do that? In order to do conversions. So here is the guide to calculate atoms or moles. We need the quantities that are given, plan a conversion factor, use Avogadro's number, and set up the problem. How many copper atoms are in 0.5 moles? So we have 0.5 mole, and we want to convert that to atoms. So the conversion that we're going to use places moles here and atoms here. 1 mole equals 6.02 times 10 to the 23rd atoms. So what we do, we multiply these times that, and then our answer will be 3.01 times 10 to the 23rd atoms. The next problem is how many moles of CO2 are in these many molecules. So we're going to set up the problem. We have 2.50 times 10 to the 24 molecules. So then we're going to set up in a way that molecules are here and moles are here. 1 mole equals 6.02 times 10 to the 23rd molecules. Take this number divided by this, and the answer is 4.15 moles. The subscripts in the atoms give you the number of moles. So for example, 1 mole of C9H8O4 has 9 moles of carbon, 8 moles of hydrogen, and 4 moles of oxygen. These subscripts are given the relationship where they need to combine. We can use 6 moles of carbon or 6 atoms of carbon, 12 moles of hydrogen or 12 atoms of hydrogen, 6 atoms of oxygen or 6 moles of oxygen. And with this, we can write conversion factors. For example, given this formula over here, we could say 1 mole of aspirin equals 9 moles of carbon. 1 mole of aspirin equals 8 moles of hydrogen, or 1 mole of aspirin, 4 moles of oxygen. And each conversion factor has its inverse. So the problems that we're going to do is calculate moles. We're going to get the given units, have a plan, write the equalities of the conversion factor, set up the problem, the math. So let's do these two problems together. How many moles of carbon are present in 12.3 moles of this? So we have 2.3 moles of this compound. And we need to know how many moles of carbon. So we know that in 1 mole of this compound, we have 5 moles of carbon. So what we do, we multiply this times this, and the answer will be 11.5 mole of carbon. Next question, how many atoms of oxygen are in these many moles of this? So we have 0.15 moles of this compound. And we want to know atoms of oxygen. So the first thing is know how many moles of oxygen we have. In 1 mole of this compound, we have 8 mole of oxygen. We're doing oxygen. 4 mole of oxygen. So we multiply this times 4 and we get the number of moles of oxygen. The number of moles of oxygen is 0.6 mole. Now, this mole needs to be converted to atoms. In 1 mole, I have 6.02 times 10 to the 23rd atoms. So just multiply this times this, and the answer will be 3.61 times 10 to the 23rd atoms.